This is Forces Lesson 7. This is work done on force. So the objectives of this one are to explain that when a force is applied that moves through a distance, work is done, and to recall and apply the work done equation. So, work. When a force causes a body to move through a distance, energy is transferred and work is done. So essentially work done is equal to energy transferred. Both work and energy are measured in joules. So work and friction. Remember, if you want to make any notes, just pause. So work done against frictional forces is mainly transformed into heat. So, quick example you can do sat there is to, quickly rub your hands together. Rub your hands together and, you'll generate a lot of heat. So in terms of work done in cars and stuff like that, brake pads become very hot if they're applied for too long. In this case, on this race car, some of the car's energy may have also been transferred to sound in the form of a squeal. So essentially frictional forces between surfaces result in the transfer of energy. And as you can see in this one, it will be the kinetic energy of the car transferring into the thermal energy of the brakes. So work done equation. So work done is force applied multiplied by distance moved. And they've got to be in the same direction. So work is measured in joules, force in newtons, and distance is measured in meters. So if you want to get that down, and then I'm going to give you the shortened version of it in a second. Remember to pause if you need to at any point. So the equation in full would be, well, in shorthand writing, work done is equal to force multiplied by distance. Now you can use D or you could use S, it's completely up to you. Normally I'd just do this one. So work done is F times D. And remember, work done is measured in joules, force is measured in newtons, and distance is measured in meters. Alright, let's apply this then. So nice and straightforward. So if you want to have a go at this, you can. Obviously, calculate the work done when a force of 5 newtons moves through a distance of 3 meters. So really straightforward. So write the equation. So work done is force times distance. And then just put the numbers in. So the work done is equal to the force, which is 5, multiplied by a distance of 3 meters. And obviously 5 times 3 is 15 joules. Really straightforward. Let's move on. So in this one, just be careful. Let's pause and have a go. Calculate the work done when a force of 8 newtons moves through a distance of 30 centimeters. So once again, nice and straightforward. Work done is force times distance. So work done is equal to the force, which is 8 newtons, multiplied by distance. And you have to be careful with this one because it's 30 centimeters. Obviously, there's 100 centimeters in a meter, so that's just 0.3 meters. And then 8 times 0.3 will give you 2.4 for the work done. And obviously, it's measured in joules. Hopefully that one's okay. Let's try another one. So this one, if you want to pause and have a go, calculate the value of the force required to do 800 joules of work over a distance of 50 meters. So once again, work done is force times distance. Hopefully you've got all these right and you're just checking your answers. So the work done for this one is 800 equals the force, which is what we're looking for, so we'll call that F, times 50. Then remember, we've got to make F the subject, pretend you're in a maths lesson, and we've got to get rid of the times 50. And the opposite of timesing by 50, to get it to the other side, is dividing by 50. So 800 divided by 50 gives us a force of 16 newtons. Hopefully that's okay. Let's do some more. So this one we're calculating the distance. So same again. But this time we've got 10 newtons and 72 joules. So work done is force times distance. So FD And then just put the numbers in. So the work done is 72 joules equals, force is 10 newtons times the distance d. And once again, make d the subject. Opposite operation of timesing by 10 is dividing by 10. So 72 divided by 10 will give you a distance of 7.2 meters. So let's try another one. A little bit more maths on this one. Let's take through the answer now. Calculate the work done by a child of weight 300 newtons who climbs up a set of stairs consisting of 12 steps, each of height 200 millimeters. Now we have to be really careful with this one. So work done is force times distance. Now the force in this question is going to be the force that you're doing work against, which will be the weight of the child. So the force is 300, and what we need is the vertical distance that we're doing, because we're doing work against gravity. So what we've got is 12 steps at 200 millimeters each. So in terms of millimeters, remember there's 1,000 millimeters in a meter. So to go from millimeters into meters, we need to divide by 1,000. So 200 millimeters divided by 1,000 gives us 0.2 meters per step. Then we've got 12 steps, so we need to do the 0.2 multiplied by 12 steps. So that gives us 2.4 meters. Then the work done is simply force times distance. So work done, the force that we're overcoming is the weight, which is 300, multiplied by the 2.4 meters. So that gives us a work done that's equal to 720 joules. Hopefully you got that right, and if not, you followed it okay. If you want to redo it, just have a go again. Let's move on. So let's complete this. So pause and fill those in. So the first one is simply work done is force times distance. So I'm just going to put the working out up here. So FD. So it's just 50 times 3. So 50 times 3 gives us 150 joules. The next one. So once again we've got, so this is number 2. So the second one, work done is force times distance. So 800 equals the force F times 20. So to get F as the subject, we need to get rid of the times 20, so divide by 20. So if you do 800 divided by 20, you get 40 newtons. So the third one, so once again, work done is force times distance. So work done is 500 equals 250 times D. So to get distance on its own, we need to get rid of the times 250, so divide. So 500 divided by 250 gives us 2 meters. This one's a bit tricky because of the units. So work done is force times distance, so I'm just going to put this one at the bottom. So work done is force, which is 4,000, times distance. Now 2,000 millimeters, remember that there's 1,000 millimeters in a meter. So 2,000 divided by 1,000 just gives us 2 meters. And 4,000 times 2 is 8,000 joules. But it wants to give an answer in kilojoules. So kilojoule, kilo means 1,000, so 8,000 joules would just be 8 kilojoules. Hopefully that's okay. Now this one, if you've not seen this before, now you have, capital M. So capital M means mega, so that means 2 megajoules. And 2 megajoules is 2 million. So let's have a look at this one. So I'm going to do working out at the bottom here. So work done is force times distance. So the work done is 2 million. If you're good at maths and standard form, you could just do 2 times 10 to the power 6. If you've not done that, it's 6 zeros equals the force F times distance 5 kilometers. So 5 kilometers means 5,000 meters. So we need to make F the subject. So we need to get rid of the times 5,000. So it's divide by 5,000. So 2 million divided by 5,000 will give us a force of 400 newtons. Hopefully that went okay. Let's finish with a word fill, close exercise. Might be good for some notes. If you want to try it without the keywords as help, you can attempt that now. You can either write it out or 1 to 8, put the correct word in the correct order. I'm going to put the help words on now. And then I'm going to go for the answers. So work is done when a force moves through a distance. The amount of energy transferred is also equal to the work done. When a car brakes, energy is transformed into heat. Work done is equal to the force multiplied by the distance moved in the direction of the force. That's obviously important. They've got to move in the same direction. The work done is measured in joules. If the force is measured in newtons and the distance is in meters. So we found that helpful. Thanks for watching, and I'll see you at the next video.